So we've dealt with the common logs of base 10. So the question is, can we have one that doesn't have a base of 10? And the answer is absolutely. So before I go there, let's just write down some common ones here. Let's take the number 5. 5 to the 0 is 1. 5 squared is, oops, I missed 5 to the 1. Just 1 second. 5 to the power of 1 is 5. 5 to the power of 2 is 25. 5 cubed is 125. And 5 to the 4th is 625. Those will help us as we try and solve some problems. So what if I want to write the log of something? So let's say I want to know what the answer is for the log base of 5. So when you have a base of 5, what we do is we put a little subscript here of 5. And this tells us what base we're dealing with. So if I said, what is the log base 5 of 5? Okay, and when I see that, what I naturally want to do, I'll put a little arrow here, is I'm going to say, well, log base 5, that's 5 to the 1. And what we want is we want these two numbers to match. And when those numbers match, the answer is simply the exponent. Let's do another one here. Log base 5 of 25. That's the same as saying the log of base 5 of 5 squared. Once again, this tells us that I want the base of the number to be the same. So the answer is 2. Let's do another one here. So if I ask what is the log base 5 of 125, then once again, I'm going to say, well, that's the log in base 5 of 5 cubed. This and this match. The answer is 3. And the last one of these, log base 5 of 625. And I'm sure you've realized already that the answer here is 4. Okay. Keep in mind that we also can do some negative answers. So what is the log in base 5 of 0.2? Now the 5 here gives me a hint, okay? But what I know is I know that 0.2 is the same as saying 2/10, and 2/10 is the same as 1/5. And 1/5 is 5 to the negative 1. So the log base 5 of 0.2 is equivalent to saying the log base 5 of 5 to the negative 1. And the answer to that is simply negative 1. Let's try a couple other examples with a different base. So here I have a log base 2 of 16. So what I'm going to do is I'm going to take 16, divide it by 2, and I get 8. Divide that by 2, I get 4. 4 divided by 2, I get 2. So what I just figured out was that 16 is the same thing as 2 to the power 4. So this is going to be log base 2 of 2 to the 4. Okay, 64. Once again, it's base 2. So I'm going to take 64 divided by 2. That's 32. Divide that by 2 is 16, and so on, so on, so on. So I know that the log base 2 of 64 is equivalent. I'm going to draw as an arrow here. Log base 2 of 2. Now let's see, that was 4. That was to the power of 6. Okay, so log base 2 of 2 to the 6 is 6. Oh, be careful. Look at this. This is a base 4. Okay, well, I know that 4 squared is 16, but I could have taken 16 and divided by 4. So let's see. So log base 4 of 16, I'm going to say that is log base 4 of 4 squared, which is 2. Oh, log base 4 of 64. So let's see. 64 divided by 4 is 16. Divided by 4 takes me to 4. So log base 4 of 64 is the same thing as saying log base 4 of 4 cubed. The answer is 3. Once again, here I am, log base 3 of 27. That's the same thing as saying log base 3 of 3 times 3 times 3. The answer here is 3. Log base 3 of 81. Is there a common one? Sure is. That's 3 4 times. Okay, so the secret really when you get these kinds of questions is, can I take this number and write it as an exponent? And if you can do that, use this number as the base, and it gets really, really simple. There's one other log that I need to point out. Okay, and we have a special number called e. You may have already seen this in some other things. And e is a special number. It's somewhere around, it's kind of like pi, 2.71. And when you have, the log base e of e, I guess that's just going to be 1, or log base e of, let's say, 2.71. It's a rounded off answer, same thing. But what we do is we give this a special name. This is a natural logarithm. Okay, and the natural logarithm, we just write it as ln for the natural log. Okay, so you'll see that on your calculator. Normally, if we don't say what the base is, it's base 10. And if we go base E is the natural logarithm.